Okay, first example says to show that the polynomial has no rational zeros. So the first thing I need to do is compile the list of actual possible rational zeros, and then we will test from there. So that theorem that you guys wrote down that made absolutely no sense to you, says that to compile this list, we take all the factors of our constant, which here is 2, and divide it by all the factors of our leading coefficient, which is 1. So we always use the constant for our numerator factors, and we use the leading coefficient for our denominator factors. When I talk about the factors, I talk about numbers that multiply into that number.
It would be negative.
No, because we include the positive and the negative versions.
Okay.
And we always do the positive and the negatives. So what numbers multiply together to get 2? 1 and 2. So I have to include positive negative 1 and positive negative 2. Divided by what multiplies together to get 1?
1.
Just 1. So I have to include positive negative 1. So from here, I'm going to take each of these factors and multiply it by each of these factors. I chose this example because it's going to give us a very short list. So then my possible rational roots for that polynomial, I call it PRZ for possible rational zeros.
Wow.
I know, right?
President.
Magical.
I wish I had like 1,600 colors I could color code this.
And I just start dividing. What's positive 1 divided by positive 1? 1. What's negative 1 divided by positive 1? What's negative 1 divided by positive 1? If it's already on the list, I don't have to list it again. And then negative 1 divided by negative 1 gives me a positive 1. Then I do the same thing with 2. 2 divided by 1 is 2, and I include the positive and the negative version. So then this gave me a very short list of values. I could do synthetic division with all of these, but there's only 4 of them, so there's got to be a faster way. What's another way I can determine whether or not a number I'm dividing out is a factor?
Oh, plug it in and see if it equals 0.
Plug it in and see if the answer I get equals 0. Since there's 4 of these, that's definitely doable. So we're going to go ahead and use that avenue instead of synthetic division. So I'm going to solve this polynomial at 1, at negative 1, at 2, and at negative 2. And we're going to see what numbers we get. So everybody go ahead and do that on your papers.
So when would you use synthetic division?
When we have a larger list that we want to break down by finding bounds as well as zeros. But since there's only 4 of these, it's not worth it.
And you're not finding them.
Right, because there's only 4 of them. Yes.
Do we have to fill in for the list?
Say that again.
Like if there's an X, there's no X too. So
We do not have to fill in for zeros here. No, we just plug it in the way it is. Because if I filled it in, it'd be 0 times that X, and 0 times anything is just 0. So it doesn't change my value at all. That's a good question, though.
Would we use it with synthetic?
Yes.
Okay.
For synthetic, we do have to fill in the zeros. What do I get when I plug 1 in? Negative 5, which is not equal to 0. So positive 1 is definitely not a factor or a 0 of that polynomial. What do I get when I plug in negative 1? 1. Again, not equal to 0. So that cannot possibly be a factor. What about when I plug in 2? I do get negative 2. Again, not equal to 0, so 2 is not a factor. What happens when I plug in negative 2?
Negative 2.
Again, not equal to 0. So I have just proven that this polynomial has no rational zeros because none of the rational options I got worked. It still has 3 zeros, but they're all going to be complex, which is kind of cool. We're not going to find them, but they do exist.
Are we going to find them later on the lesson?
I never say never.
You
Okay,
will sneak
so
in.
if you have a really short list and you don't want to do synthetic division, just plugging it in is an option for determining whether it is or is not.
Would you do synthetic division?
a single problem? Then why not just plug in all of them anyway?
Because if I have a list of 30, even if it doesn't work as a factor, it could be a bound, which could eliminate half of my list. So it's worth it to do the synthetic division for larger lists. You don't have to. You could absolutely plug in 30 numbers if you wanted to.
Synthetic divisions.
Oh yeah. You don't always have to do 30. If you get it down to a quadratic, you can just quadratic formula it out. It's not that big a deal. Okay. Does this make sense to everyone?
Yes, but not the one that's supposed to be managed.
That's okay. We're gonna do more.
So there's a 30 exponent on there.
No, but even if I had x to the 5th, I could have 30 possible rational roots that I have to narrow down. It's I think last year I gave a problem that had like 65 rational roots, possible rational roots.
Yeah, why would you?
Wait, what now?
I mean, then an hour and a half.
You're trying to make us cry?
Say that
You
again.
cannot do that this year.
Wait, say that again.
I'm not
You
going
gave
to. I'm just gonna make it
65
bad.
possible what?
Possible rational roots. So their list had 65 numbers on it.
Give it only together.
Listen, I will make that bet. I will make that bet.
Okay, next example. If I gave you one that had 65 possible rational roots, I would just, in the instructions, say find all possible rational roots, not actually find the ones that work. I'm not that mean.
Like you're doing right now.
Yes.
Think I have enough paper to finish that?
Is this the really long one?
It is.
So I don't have enough paper today.
Ah,
Not for the whole problem.
It's like a third of a page. I could have used my other page for that. We'll just start a fresh one.
Okie dokie.
what?
So this example says to find all rational solutions to this polynomial. This means that not only do I want to list the possible rational zeros, but I want to find the ones that work.
Oh, no.
Really one
I
of the
forget for factors of 8.
Okay, are we ready?
No.
Go for it.
Sure.
The first step, when I say to find all of the possible rational roots, or if I say to factor completely, they mean the same thing. You have to start with a list of possible zeros that could work. In order to do that, I have to do the factors of my constant divided by the factors of my leading coefficient. So my constant here is 8. My leading coefficient is 3. Bless you. What multiplies together to get 8?
2.
1 and 8,
1 and 2, 4.
2 and 4. So I like to do numerical order. So 1, 2, 4, and 8, positive and negative. There is no wrong order here though, so if you wanted to do like 1, 8, then 2 and 4, that's fine. Oh goodness.
Really?
What are my factors that multiply together to get 3?
3.
1 and 3, positive and negative.
Oh boy. I love that.
It's fun. Come on, yes.
Will we ever have to find out factors of -3 or like?
No, because I always include the positive and the negative versions, so the sign in front does not matter.
Okay, I was gonna say for negative.
No.
negative.
Okay, are we ready?
Oh,
Yay, okay.
Yes.
So my list of all possible rational zeros, or my PRZ, I just like to move left to right. What's 1 divided by 1?
1.
So I include the positive and the negative of that. What's 1 divided by 3?
1/3.
Positive and negative.
Yeah.
What's 2 divided by 1?
2.
2 divided by 3 is 2/3. 4 divided by 1 is 4. 4 divided by 3 is 4/3.
Slow down.
8 divided by 1 is 8.
Wait, hold up.
I'm just listing them.
You're going really fast.
Yeah, and I can't even comprehend what's going on because you're already on the list.
Okay, I'm not done
Oh,
actually.
you
I'll
know,
wait.
it's a negative thing
Not
like that.
Yeah, you don't have to list them out separately. I like them listed separately because it looks better, but
Man, I'm just gonna finish it out the way.
okay. So then I did 4 divided by 1 is 4. 4 divided by 3 is 4/3. 8 divided by 1 is 8. 8 divided by 3 is 8/3. We include the positive and the negative, all of them. And then there's my list.
Oh my.
Let's go.
Oh, that's short, man. That's a short list.
That's
It's
short.
13. It's like 14. No. 16.
Again, if we got any that repeated, we only have to list them once, so keep that in mind. So now what we do from here is we need to start testing. Obviously, we are looking for ones that come out to a remainder of 0, so they are factors. But by coincidence, we can also find upper and lower bounds, which will help us eliminate some of the values. So I'm just going to ask, where would you like to start?
Right now.
Well, we don't know what the bounds are. We just pick a number and start testing. 8. I wouldn't want to start with 8, but okay. We'll start there. No, she said 8. Let's do it.
Why?
said you.
There's only one value at 8, and it's 8.
Okay, synthetic division. Make sure we're not skipping any terms. I have 3, 14, 14, negative 8, negative 8.
Oh God.
Wait, what now?
We are doing synthetic division to start dividing these out and seeing if any come out to be factors
So
or bounds.
why is she doing -8? What's going on?
I heard 8, so now we're doing 8.
Once you get your list, then you take.
We pick a number on the list. And I heard 8, so we're doing 8.
We're doing 8, guys. Come on.
That's the number I heard. That's the number we're doing.
I don't know.
And then I'm just going to go ahead and do synthetic division.
You got your first term. It's 3.
Okay, let's do the synthetic division. The first coefficient drops down to the third row. 3 times 8 is 24. 14 plus 24 is 38.
You want to tell me what the next number
38 times 8 is 308. No, 304.
Yeah.
Should be 304.
Gosh.
304 plus 14 is 328. Oh my God.
Who let
Okay.
me pick this number?
No,
4.
it's 15, bro.
Oh my gosh. 6, 16, 22, 26.
This is a good one.
2,624.
This is gonna turn out to a 0. I just feel.
Negative 8 plus 2,624 gives me 2,616.
It's right. It's 318,
It's
bro.
318 after 28.
Is it 318?
I said
Yeah.
that, and I thought that was the answer for 318. Silly.
Hey,
Okay.
that's our
Oh, it is
teacher.
318. Just kidding.
Show some
Okay.
respect.
Hey, I did the multiplication right. I'm counting that.
Wait, really?
Yeah, the 30 to 304.
Wait, so
Oh,
we
the
erase
multiplication.
everything I just worked so hard for?
Let's say.
I don't know how you're doing any of this in your head.
8, 14. So 2,444 minus 4, 2,436. And then 2,436 times 8 is not going to give me a 0.
No.
But it is going to be some positive number, right?
Yeah, which gives you
Which means if I had any numbers larger than 8 in this table, I could eliminate them. Because this is an upper bound for this set. However, 8 was the largest possible value that I found.
discovered it.
So we can go ahead and eliminate
Yours is lower than 8.
positive 8.
Wait, so that's a positive bound?
Not even 3.
Yeah, it's a positive. It's a positive bound. We can have more than one.
Okay, I'm gonna write down what you said all the numbers.
So
are
we could
positive.
eliminate any number larger than 8 as a possible 0, but there was no number larger than 8. Yes.
So what's the positive 8?
Huh? Because it didn't come out to remainder of 0, so it's not a factor. So then I pick another number.
2.
And I do this all over again.
Wait, we don't have to.
Two.
Please do
Wait, no,
two.
it's just gonna-
Please.
2.
Right, because I knew it wasn't going to come out to 0. I
2.
2?
Two.
Okay, let's try 2. And then we'll do one after that. 'Cause that's the next one I heard.
I just erased the.
Yeah. 3, as I said, when I do a lot of these, I like to draw the table in pen and then fill in the numbers with pencil, and I can erase it really easily.
Oh, I should.
Or you can do a whiteboard too, that's fine.
Okay, I was gonna say.
Okay, drop the 3 straight down. 3 times 2 is 6. 14 and 6 is 20. 20 times 2 is 40. 40 plus 14 is 54. 54 times 2 is 108. Minus 8 is 100. 100 times 2 is 200.
Positive.
Minus 8 is 192. But they are all positive. So even though positive 2 didn't work, it is an upper bound, which means positive 4 is not going to work. And positive 8 over 3 is also not going to work because those were all positive numbers that were bigger than 2. Because 2 came out to be an upper bound for this.
Should we write down our upper bound right now?
No, because we could have more than one. So you can make a note.
So I cross out 2, 4.
2, 4, and 8/3.
This is why you do this all.
This is why we do synthetic division, yes, because it allows us to find the bounds and eliminate more numbers.
So when
Go to
you-
the plus minus.
Right. So I just eliminate the sign.
So
Or
when you
erase the
find
sign.
an upper bound, then you just eliminate
Anything bigger than it that existed in my table or my list. So I took out everything bigger than 2, and I took out 2 because it didn't give me a remainder of 0.
This is really stressful.
It is super stressful.
In 45 minutes, you expect this?
Okay. That one didn't work. So let's try 1 next.
Please tell me one word.
Positive 1, because that's the other one I heard after you said 2.
Please tell me one word.
Positive one?
15.
So if you did it for the negative, it would just do the same thing, only cancel out the negative
We'd be looking for alternating terms though for a negative.
for negative.
Okay, so we're trying positive 1. We drop the 3 straight down. 3 times 3 is 3. 14 and 3 is 17. 17 times 1 is 17. 14 and 17 is 31. 31 times 1 is 31. Minus 8 is 23. 23 times 1 is 23. Minus 8 is 15. So it did not come out even, but it did come out with no sign changes, which means I can eliminate any value larger than 1 still left in my table. That doesn't leave a whole lot, but it allows me to eliminate 4/3. Positive 4/3 anyway. Because that was the only other number bigger than 1 left in my table. Which means I'm going to have to test a fraction next.
1/3.
You're
No.
hilarious.
1/3?
One
You're
third.
hilarious.
One third.
I'll try 1/3. Is
Yeah.
that what we're going with? Yes,
Yeah.
Joe.
Why do you go through the positives? Couldn't you do a negative?
We could test a negative now,
Okay.
but I want to see if there is a positive answer too, because that kind of sounds fun. We don't have to. That's perfectly fine.
The negative number can be number, right?
No, a negative number can only be a lower bound.
Oh, so they're fine. So it has to be.
If we have a positive, we don't know. Do you guys want to test a negative number next? Just because I'm
I
tired
want
of
to
the
test whatever's
positives.
gonna give us
Yeah.
yeah. So we can move
After
on.
1/3.
We want to test 1/3 first?
I
Okay.
don't know what else now.
No, turn it to your 15 bucks.
Just like, wait, what if there's no positive zeros?
No,
Is
there's no
0
upper
also
bound.
like a bound kind of?
Wait, are we doing 1/3 or what? Or what?
I think Gabe wants to try 1/3. Yeah.
Oh.
So let's try 1/3. What's 1/3 times 3?
What?
1. 14 plus 1 is 15. 15 times 1/3 is 5. 14 plus 5 is 19. 19 times 1/3 is 19/3. Oh boy.
Negative 5/3.
Yeah, negative 5/3. Times 3 gives me negative 5/9. Which is going to give me what?
A negative number.
It's going to be negative 77.
Yeah.
Nice.
Negative 7.
It is not an upper bound, and it is not a 0. Which means if I have a positive bound, if I have a positive root here, it's going to be 2/3. Do you want to test it, or do we move on to the negatives?
Negatives.
Okay.
Wait, what do you
I
mean?
hate 2/3. Like, oh, I always hate 2/3.
How about we go ahead and test a negative just to get a change of pace? I would like to test negative 2.
Oh.
If I test a negative and I come out with alternating signs, That negative is a lower bound, which means I can eliminate anything smaller than it. Okay, so keep that in mind. 3 times negative 2 is negative 6. 14 minus 6 is 8. 8 times negative 2 is negative 16. 14 minus 16 is negative 2. Negative 2 times negative 2 is 4. Negative 8 plus 4 is negative 4. Negative 4 times negative 2 is positive 8. Negative 8 plus 8 is 0. So negative 2 is a factor for this polynomial. So what I like to do once I found a factor is to rewrite my polynomial as factors of the quotient that's left in the factor I just divided out. Because I had x equals negative 2, when I change it into a factor, it becomes x plus 2. So this comes out to be x plus 2 times, this is my constant, my x term, my x squared, and my x cubed. So I'm left with the quotient 3x cubed plus 8x squared minus 2x minus 4. We all good there? This actually is very helpful because this and the original polynomial I started with are going to have the rest of the roots be the same, which means any root that could possibly work has to have a numerator that is a factor of 4 and a denominator that is a factor of 3. Which means if I go back to this list, 8 is not a factor of 4. Right? Because 8's bigger than 4. So I can now eliminate negative 8 and negative 8/3 because they no longer work as factors for this cubic I have left. Which has helped me narrow this down even farther. I also like to set up a new synthetic division table using the coefficients from this cubic I found because there's less numbers to work with. You are more than welcome, of course, to keep using the original polynomial. It's your choice. So now what I would like to do is set up my synthetic division table using these numbers. So I have 3, I have 8, I have negative 2, and I have negative 4. And this list are all the possible values that I have left. What do you want to try now?
Negative 4.
Okay. Let's try negative 4. The 3 drops straight down. 3 times negative 4 is negative 12. 8 minus 12 is negative 4. Negative 4 times the negative 4 is 16. Negative 2 plus 16 is 14. 14 times the negative 4 is negative 64, which leaves me with a negative 68. Hold on, 56, yeah, I knew something didn't look right there. I still don't like that.
Oh, it's negative 4.
Okay, maybe I do, I don't know. I don't know basic things. Okay, so I got negative 16, did that work? It did not come out as a factor, so I could eliminate it, but it is a lower bound. So if I had any numbers left on my list that were less than negative 4, I could eliminate them. Do I have any left? No. But it did help me eliminate negative 4 from my list. So now I have 1, 2, 3, 4, 5 numbers to test. What would you like to test next?
Negative 1/3.
Hey, I have a question.
Yes.
Why did it not eliminate anything lower?
Because I didn't have any number that was less than negative 4 left on my list. Right. Negative 1/3?
Yeah.
What if I said negative 2/3? Okay, let's try negative 2/3 just to see what works.
Yeah. What if I said this though?
Yeah, I'm fine with that.
It is good to test a fraction though.
My favorite things are negative fractions.
I bet they are. Okay,
You like
what's negative 3 times a negative 2/3?
Negative 2.
Negative 2. 3 times a negative 2 is negative 6. Divided by 3 is negative 2. 8 minus 2 is 6. 6 times a negative 2/3 Dave's not allowed to answer anymore. -2 and -4 give me a -6. What's -6 times a -2/3? 4. 4 and 4, or -4 and 4 give me 0.
That's why you said.
Which means x equals -2/3 can be turned into a factor, which makes it x plus 2/3. So now my polynomial looks like x plus 2, which was the first factor I found, times this new factor, x plus 2/3, times the quotient I have left. I have a remainder, I have an x, and I have an x squared. So I have 3x squared plus 6x minus 6. Once it's down to a quadratic, I can just use the quadratic formula to finish it out. No more guess and check necessary. So let's go ahead and do the quadratic formula to finish factoring. Oh, that was bad. That out. On your own, go ahead.
What do I decide to do?
Do we have to?
I didn't say that it had to be irreducible over the set of real numbers, so it's entirely possible that we'll get imaginary answers, and that's fine. I love this. These are seriously my favorite problems.
That's weird.
Don't judge. Are we done with the quadratic formula yet? Almost? Okay, I'll give you guys another minute. Real question though, how many of you guys kind of like this? A couple of you. How many of you detest it with every fiber of your being?
This isn't.
Okay.
It's just tedious.
It's not like hard.
Right. It's a little tedious. I do agree. But
I would much prefer that than something that I'm like.
Yeah.
Well, my brain is worked.
okay. So when I did the quadratic formula on this, I got x equals what?
1 -1 minus the square root of 3.
That what you all got as well?
I got 108.
You definitely should have gotten that. So you'll have to go back and check that later. Which means, since those are my zeros, I can rewrite them as factors by just subtracting them over, right? So when I write my factors, I have x plus 2. I'm going to rewrite this so it's all linear. So 3x plus 2. I just kick the denominator over with the x. And then I have x minus -1 plus root 3. And x minus -1 minus root 3. And then those are my factors or my zeros for this polynomial. You could also write them if you wanted to as a list of zeros, which would be -2, -2/3, -1 plus root 3, and -1 minus root 3. That would also be acceptable.
Do you have to distribute the
Wait, why did you write 3x?
You could, yeah.
Find all rational solutions.
Where'd you
Because
get
I
three?
just kicked the 3 over with the x, so it was all one.
Oh, for that one.
Yeah, I didn't like the fraction in there.
I didn't write that right.
Okay, so this is the end of this problem because we factored it out completely and we are able to find the zeros from here, which means we're going to go ahead and do another example. And the last example I don't think we're going to get to. It is a story problem and it's all the last page of the notes. So I do want you to go ahead and take a look at that. And if you have any questions, of course, ask me on Monday and I'm happy to go over it with you, okay? So the last example I would like to do. That good?
Yeah, I just.
Okay.
Does that mean homework is not due Monday anymore?
No, your homework's still due Monday.
At best, we get 2 days now.
the exact same.
Yes, I'm gonna show you a different way of doing it, that's all.
Oh, this way, like, not as, like,
I think it's equally as tedious. But some people might like this way better. Okay, so because this is one that we've already done, we already have our list of zeros, so I'm gonna go ahead and write them out. This example allows us to do it without maybe as much synthetic division. And the alternative to doing all that synthetic division is to graph this equation. You can do it on your calculator. You don't have to do it freehand. It's fine. So graphing it on your calculator. I'm just doing a rough real quick and then I will fill it in. Okay. So if I were to roughly graph this from my calculator, it would look like this.
dang, son.
This is in the notes, so you don't have to write the graph right now. Just pay attention to what I'm about to say, okay? If it is a rational zero, that means that the zero occurs where my graph crosses the x-intercept, or the x-axis, sorry. So I can use this graph to approximate where those x-intercepts are, right? Like if we notice, we have a section of the graph that crosses between -3 and -2. I also have a section of the graph that crosses at -2. And I have a section of the graph that crosses between -1 and 0. And then I also have a section of the graph that crosses between 0 and 1. So using these intervals, I can find values from my list that fall within these intervals, and I can test them using synthetic division. So it gives us a direction. So are there any numbers on this list that fall between -3 and -2? Say it again. -8/3 falls between -3 and -2. What about, I got x equals -2, so that's automatically going to be a 0 for me. So that one works. What about between -1 and 0? Do I have any values here that I could test?
Positive.
Between -1 and 0.
Or -2/3.
-1/3 and -2/3. So I have 2 there that I can test. What about between 0 and 1? +1/3 and +2/3. I can tell just by looking at this is probably not going to be +1/3, right? Because it looks closer to being 2/3 of the way across. Similarly, over here, it looks closer to 2/3. You can still test them both, though. By doing this, I only have to do 5 synthetic division problems instead of doing 13 or 14, however many problems we had, or however many factors we had. And then if it didn't come out to a remainder of 0, then it's not a 0. Yes?
To find like the around the zeros, can you still do that one thing where you put the point there?
Yeah, absolutely. And you could always use your calculator, like she's saying, to actually find the zeros if you wanted to. You can do that, but you should know how to do it this way as well, so that when I give you a no calculator portion of the test and I ask you to find the zeros, you know how.
Oh, yeah, I won't do it.
Right, but yes, you can do that, especially to check yourself. That's fine. Okay, so this is just kind of a shortcut where you don't have to do as much synthetic division, you're more than welcome to do it like we did in the beginning, like when we did the problem the first time. But this will work just as well. Okay, and it also helps me to realize that all 4 of these are going to be rational numbers, right? They're all going to come out to work in some capacity because I had 4 crosses of the x-axis, and this is a degree 4 polynomial. So I shouldn't have any i's in my final answer. So this also helps kind of there. Okay? Any other questions, concerns, or issues with this? As I said, there is a story problem on Canvas. It is the last page of the notes. Please look at it. Please really look at what I did on it. And use that because I do believe I gave you a story problem on the note, on the homework. Other than that, this is complex and rational zeros of polynomials. How do we feel about it? 1 to 5, how do we feel? It's not overly difficult, it's just tedious, and I get that. Okay.
Well, you do the homework first, okay?
Yeah, there you go.